So let us go with the next concept, that is reaction of acid chlorides and anhydrides. So here the concept tells that when an acid chloride is made to react with an alcohol, we are going to get an ester. So esters are obtained when an acid chloride is made to react with an alcohol along with the formation of HCl. In the same way, when anhydride or an acid anhydride is utilized, this acid anhydride upon reaction with alcohol also gives esters along with the formation of an carboxylic acid. Now let us analyze how this particular chemical reaction takes place. Acid chloride is given by the formula RC double bond O R dash. So this is called as an acid chloride. So when this acid chloride is made to react with an alcohol, that is R dash OH. So this R dash OH ionizes as R dash plus as well as OH minus. RCOCl ionizes as RCO plus and Cl minus. So this RCO plus has to combine with what? OH minus. So now a question arises, how this acid halides and an alcohol give rise to an ester. So here what happens? Alcohol is usual ionization is R plus and OH minus, but in this case it forms RO minus and H plus, because here chloro group is an very good leaving group. This very good leaving group chloro will takes away H plus, so that there will be an formation of an ester RCOOR dash along with the formation of HCl. So one has to understand that this is the most common ionization, but chloro being a very good leaving group, it takes away the hydrogen as a proton to form RO minus along with H plus, where it can readily yield ester as a major product. So basically, when we discuss with some of the example related to this, let us consider a particular example, CH3COCl, which is called as acetyl chloride. When this acetyl chloride is made to react with ethyl alcohol, so chloro being a very good leaving group, it takes away H plus, so that this ionizes as what? C2H5O minus and H plus. This forms CH3CO plus and Cl minus, so that we are going to get HCl along with the formation of CH3COO C2H5, which is known as ethyl acetate. But this particular reaction takes place in the presence of pyridine solvent. Since acetyl group is added in this particular reaction, we can call this reaction as acetylation reaction. It can also be called as acetylation reaction because acetyl group is readily added to the reactant. Here acid chloride or acetyl chloride, when it is made to react with an ethyl alcohol or ethanol, ethyl acetate is readily obtained. Hence acetyl group is present in this, which can also be called as acetylation reaction. So in the same way, when I consider an example with relevance to acid chloride, we have discussed acid anhydride. Suppose if I take an acid anhydride, let us discuss the general reaction. So this is the general reaction for an acid chloride. Now let us discuss the general reaction for an acid anhydride. So this acid anhydride is represented by the formula RC double bond O, or it can also be written as RCO twice O, or it can also be represented in this way, which is called as an acid anhydride. So this is acid anhydride. When this acid anhydride is made to react with an alcohol, so here what happens? So we have to get an carboxylic acid group. So here one of the oxygen takes away the electron towards itself, which can readily form RCOO minus and RCO plus, so that here this alcohol ionizes as R dash plus as well as OH minus. So this RCO plus can take away what? OH minus, so that it can readily give RCOOH, which is an carboxylic acid, and this RCOO minus can take away R dash plus, which can readily form RCOO R dash, so that it has given rise to an carboxylic acid along with an ester. So such type of products are formed when an anhydride is involved in an chemical reaction. So based upon this, if we discuss a particular example for acid anhydride, so let us take an example of CH3 double bond O C double bond O CH3, which is called as acetic anhydride. So this is called as an acetic anhydride. So when this particular acetic anhydride is made to react with ethyl alcohol in the presence of pyridine as an solvent, this gives rise to CH3COO C2H5 ethyl acetate along with the formation of CH3COOH, because this oxygen takes away the electron towards itself, which forms an acetate ion that will combine with C2H5 plus. This will be C2H5 plus OH minus. So here CH3COO minus combines with C2H5 plus, which will readily give ethyl acetate along with the formation of an acetic acid. Suppose apart from using acid chloride as an reactant, suppose here we have utilized acid chloride and an alcohol. Check this. Here we have utilized acid chloride. Here we have utilized acid chloride and an alcohol. Apart from using alcohol, suppose if the reaction is taken place in the influence of a phenol, how the reaction takes place, let us discuss. So when the same acid chloride, that is CH3COCl, when the same acid chloride or acetyl chloride, when it is made to react with phenol. So here we know that phenol ionizes as phenate ion, that is C6H5O minus and H plus. This acid chloride again ionizes as CH3CO plus and Cl minus. So this C6H5O minus can take away what? CH3CO plus. So here again the reaction takes place in the presence of pyridine solvent, which can readily give rise to phenate ion O. This is CO plus. Therefore, I can write it as C double bond O CH3, which can be considered as phenyl acetate. So along with phenyl acetate, there is a formation of HCl. In the same way, if acid anhydride is involved, that is CH3 C double bond O C double bond O CH3, which is nothing but acetic anhydride. When this acetic anhydride is made to react with a phenol in the presence of sodium salt of carboxylic acid, that is sodium acetate, or the reaction takes place in the presence of concentrated sulfuric acid. So here we know it ionizes as CH3COO minus along with the CH3CO plus. Here this ionizes to form C6H5O minus and H plus. This C6H5O minus can combine with CH3CO plus, which can readily give O C double bond O CH3, that is nothing but phenyl acetate, along with the formation of what? CH3COOH, that is acetic acid. So this particular reaction explains that apart from using alcohol, even when we use a phenol, the phenol can exhibit its reaction with acid chloride as well as with acid anhydride. And next, let us discuss with a reaction called as benzoylation of phenols. So benzoylation of phenols explains that when phenol is made to react with benzoyl chloride, the product is called as phenyl benzoate. Phenyl benzoate will be the product. So such kind of a reaction can be considered as an benzylation reaction or benzylation of phenols. So this can be explained by a chemical reaction, that is phenol. When this phenol is made to react with benzoyl chloride, which is given by C6H5COCl, which takes place in the presence of an alkali, that is aqueous NaOH. This ionizes as C6H5CO plus as well as Cl minus, and we know that this phenol ionizes as C6H5O minus and H plus. Therefore C6H5CO plus can combine with what? It can combine with C6H5O minus, so that the product can be written as O minus, that is phenate ion, which can combine with the CO plus, that is C double bond O, C6H5. So this is phenyl ring, this is a benzoate ring. I can call it as phenyl benzoate. Along with this phenyl benzoate, the compound that is left out is what? H plus and Cl minus, which can readily give HCl. So the reaction of alcohols and phenols, here one important note has to be known. Either when an alcohol or when a phenol, means alcohols or phenols, when it is reacted, alcohols or phenols, when it is reacted with benzoyl chloride, alcohols or phenols, when it is reacted with benzoyl chloride in the presence of alcohols or phenols, when it is reacted with benzoyl chloride in the presence of aqueous NaOH, the reaction is called as Schotten-Bowman reaction, that is SCHOTTEN, Schotten-Bowman, BAUMANN, Schotten-Bowman reaction, which is again a named reaction.